Hello everyone, this is Abhisek Mishra from Earthscience classes. So in this video I am going to discuss some of the problems, some of the questions from structural mapping. These questions I have selected from previous GATE papers and JAM papers. So those are basically from MCQ and MSQ type. I have not included the numerical type here. I will do a separate video on numerical type questions, how to solve numerical map questions in a another video, right? So here I will discuss only MCQ and MSQ. So try to get the concepts what I am using to solve the questions. Okay? So the first question is here. This is selected from JAM 2016. So the question asked that in the topographic map, the steepest slope. What is the steepest slope in this question, in this map? Okay, so most of the time I received questions from my students that they asked what is the difference between map view and CS view, cross section view, right? Always they get confused between these two. So what is map? Suppose this is a feature, this is a mountain, right? So this diagram you can draw in cross section. You can see this thing, you can see this thing, you can see in cross section, right? This one you can see in cross section. This is cross section. This is a vertical plane. This is a vertical plane. This is cross cutting the feature, right? This is cross cutting the feature. You can see this mountain like this in cross section view, but in map you cannot see this thing. In map, what is map? This is horizontal view. This is horizontal view. That means you are watching from top. You are watching from top, right? You are watching from top of the feature. So the you cannot measure the height of the mountain. You cannot see the height of the mountain, or you cannot see this thing. Okay. So yes. So map is basically your horizontal view, and cross section is your vertical or transverse section or cross section, right? This is here. This is a vertical plane. Map means it is a horizontal plane. Okay. Suppose this is a bed. This is an inclined bed. This is an inclined bed. You cannot measure its inclination. What is inclination? The angle, the tilt angle measured with horizontal, right? This is the horizontal. So the tilt angle measured with the horizontal, this angle, this is the angle of inclination. You cannot measure it from map view. You cannot see it in the map. Of course, you can measure by using strike and all. I am not going to that part. Just basic difference I am saying. You cannot see this angle. You cannot see this tilt in map, right? But you can see that in cross section. This is your cross section. Okay. So let me clear this. So now here, what are these? What are these lines? These are contours. These are contours. What are contours? These are lines of lines joining points of equal elevation. Right? These are line joining points. Coming to that point again, let's say here it is a mountain. Let's say here it is a mountain. So this is your ground surface. This is your ground surface. Let's say it is 0 height, right? 0 meter. Okay. This is, let's say this ground surface is 0 meter. Here you will get another point of 100 meter. Here you will get another point of 200 meter. And in the mountain you are getting points of 200 meter. In the mountain you are getting points of 100 meter, like that. Okay. So if you join these points of 100 meter, if you join these points having elevation of 100 meter, that will be 100 meter contour, right? If you join the points of 200 meter elevation, that will become 200 meter contour. Okay, so I have told you this is your cross section view. This is your cross section view, so you can see this profile of the mountain. You can see this profile of the mountain. So this is 100 meter and this is 200 meter. In map, what you will see? In map, you will see like this. This is 200 meter and this is 100 meter. This is 200, this is 100. So you can see here it is a profile. This profile you cannot see in map, but you can get this contour lines. You can get this contour lines. This 200 meter contour lines is here. This 100 meter contour lines, these are here. Okay, suppose here 50 meter contours. Let's say here I'll draw 50 meter contours, then it will be projected here like this, right? So now I hope all of you understood what is difference between map and cross section. This is your map, right? And for map you are getting, okay, I can do another diagram like this, another map like this. Now I'll put the contours here 100, 200, 300 like that. So what does it mean? The center part is having lower elevation. It is map, right? This is a map view. So here you are getting that the center part is having lower elevation than the outer part. The center part is having lower elevation than the outer part. So in CS, in cross section view, what will be its profile? It's like this. It's a basin like feature. It's a basin like feature, right? Here you are getting 100 meter height. Suppose it is ground. Suppose it is 0 meter height or mean sea level 0 meter height. Here you are getting 100 meter height. So this is 100 meter. Suppose you are getting 200 meter here. You will get 200 meter here. You are getting 300 meter here, so it will be like this. So 300 meter projected here, 200 meter projected here. Sorry for the so 200 meter is projected from here and 100 meter is like this, right? So in the, while watching from above, while watching from top, you will get in one plane. You will get in one plane. You cannot see this profile in map, right? So the basic difference, what I am trying to say it here is, in basin you will go as you go inside, you are getting lesser contour value, or the elevation is decreasing, right? It is decreasing like this, 300, 200 and 100. But here as you move inside, the value is increasing. As you move inside, the value is increasing. So here this is, as you see, this is 290, this is 300, this is 310. So the value is increasing. So the value is increasing towards center. Okay. So the arrow mark is always towards downside, right? It is downside. It is off. That means the elevation is higher at the center and the elevation is lower at the outer region. Okay. So it is the direction. Here it is the upside, or here it is having higher elevation, or here it is having lower elevation. Okay, so from this you know that this is the map of a highland. This is the map of a highland or mountain. The next thing is how to know the what, where there is steepest slope, where there is steeper side, and where there is gentler side, right? Where there is steep slope, where there is gentle slope. So let me do diagram here. So this is a bed, right? So now I am trying to project, I am trying to show you in vertical section or cross section, right? This is one bed and this is one bed, right? So here it is the horizontal, here it is the horizontal, right? Let's say 0 elevation, let's say this is 0, let's say this is 0 elevation. Okay, now here it is 0 elevation, 100 meter is here, 200 meter is, this is 200 meter, this is 300 meter, right? So this is 300 meter contour, this is 200 meter contour, this is 100 meter contour. These are elevations, right? These are elevations I am showing in cross section, and this is the bed, this is the bed. Okay, so here we are getting 100 meter, 200 meter and 300 meter. In map, here it is the map, horizontal view, right? So you are getting 300 meter, like this is 300, this is 200 and this is 100, right? So for here, if it is 0, you will get 100 meter here, you will get 200 meter, double of this, 200 meter here, and 300 meter will be quite away. So 100 meter line will be here and 200 meter line will be here. You can see the difference between 100 meter contour and 200 meter contour here, 100 meter and 200 meter contour. This is the difference. So when you project it in horizontal or map, when you see it in map, then what happens? Suppose this is the map, this is 200 meter and this is 100 meter, right? So you can see the gap between two adjacent strikes. Here this strike and this strike, or sorry, this contour and this contour, okay, this contour and this contour, they are having a difference of what? 100 meter. They are having a difference of 100 meter in elevation. They are having a difference of 100 meter in elevation. Here also this contour 1 and contour 2, here also they are having a elevation difference of 100 meter. But see the distance between the two contours in map. Here this is x, this is y. See the distance between 100 meter contour and 200 meter contour in x, and see the distance between 100 meter contour and 200 meter contour in y. Okay, so the distance increases in y, the distance increases in y. Why? Because as you see here, the deep of the bed, the inclination of the bed is lesser as compared to the x. The bed in x is having a steeper dip, is having a steeper dip. The bed in y is having a gentler dip. Okay, the bed in x is having a steeper dip, the bed in y is having gentler dip. That means what? When the dip will be on dip or slope will be gentler, the contours will be spaced at a larger distance as compared to the steeper one. Okay, repeating again, when the bed or the slope, when the deep of the bed or slope of the surface is gentler, the distance of separation between adjacent contour will be more as compared to steeper bed or steeper surface. Okay, so you can see this is 330-meter contour, 320-meter contour. You can see the difference here. Here it is 330-meter contour and it is 320-meter contour. You can see the difference here. So this side is gentle, this side is steep. So it is asked which is the steepest side, which is the steepest side. So it is northerly is wrong, southerly is wrong. This is north, here it is marked, it is south, it is east and west. So it is easterly steeper, right? The steeper side is towards east and wester is gentle. Okay, moving to next question. So here this is repetition of strata. This question is from repetition of strata. It is asked in JAM 2019 in MCQ section. So figure 1, 2, 3 are outcrop patterns of 3 inclined beds P, Q, R on a flat ground. Okay, so P is the oldest, so let's mark it. P is the oldest and R is the youngest. P is the oldest and R is the youngest. That means it is deposited like this. This is P, this is Q and this is R, right? So it is the younging direction. Then it is tilted. Okay, so here you are getting some repetition of strata, Okay, so let's start folding this bed. Let's start by folding this bed. Okay, let's plot and diagram. Suppose it will be compressed like this. Suppose it will be compressed like this. It will turn into fold like this. Right? Okay. So this is R, this is Q and this is P. Okay, this is P, this is Q and this is R. Okay, so in case of, so what is this part? I am plotting it here again. I am just separating this two, right? This is one part and this is one part. So I am separating it here. R, Q, P, R, Q, P, right? Like this. So this is one part and this is one part and this is another part. Okay, so here you can see when P is at the core region, here you can see the P is at the core. P is at the core means what? P is at the center. P is at the center and Q and R they are aside. Suppose I will pass a plane like this. Suppose I will pass a plane like this. Again, what view you are now viewing in this pattern or in this diagram, in this thing what I have done it here. What is it? It is a cross section view. It is a cross section view because I have shown the inclination. This is the inclination, right? So I have shown the inclination means it is cross section view. It is not the map view. This is map view. This is map view. These three diagrams what given in question, these are map view. These are not cross section. What I have done it is cross section view. So as you pass a plane here, okay, that means a horizontal plane. If you project it into horizontal, that will become map. Okay, so if you see P at the center, then Q. If it is P, then Q, then R is it is P, Q, R. So R, Q, P, Q, R. You are getting it here. R, Q, P, Q, R in this part, right? I have just passed a horizontal plane here. We are getting R, Q, P, Q, R. So what is it? It is an anticline. Why it is anticline? Because P is the older one. You can see it is older, it is younger. So when older is at the center, it is anticline. When R is younger, when younger is at the center, in this diagram you can see R is younger and P is older. So if I will pass horizontal plane here like this, so you are getting R, then you are getting Q, then you are getting P. The diagram becomes clumsy. Let me erase. So P, Q and R, right? So it is P, Q and R. I'll pass a plane like this. Not here, I'll pass a plane like this. Sorry. I'll pass a plane like this. We are getting P, then Q, then R. Here you are getting Q, then R. So R, Q, P, Q, R. R, Q, P, Q, R. So this is anticline. Where you are getting this? The third one. What you are getting? R, Q, P, Q, R. This is CS view. This is map view, right? This is anticline. So the third one is anticline. So which one is the option? This is one of the options. This is the only one option where third is given anticline. Again, let me draw other one, syncline. This is P, this is Q and this is R. So if you are passing a horizontal plane here, so this is your CS view. When you pass horizontal means on horizontal you will see this map. This is the map. Okay, at the center you are getting R, then Q, then P, here Q, then P. So P, Q, R, Q, P. So this is your incline. This is incline. Why it is incline? Because R is the younger one. Here I have mentioned R is the younger one, P is the older one. So younger at the core is incline. So it is your first one is syncline, third one is anticline. Then coming to the second one, how the second one takes place, right? For this second one, so we know that this is fault from the option itself. The first one is syncline, third one is anticline, so second one is fault. So how to know, how to interpret it? So as you can see, I have told it here. This is P, Q and R. Then what happened? It got tilted. It got tilted like this. P, Q and R. It got tilted like this. P, Q and R. Then what happened? If it will be faulted, like this, right? This is the fault plane. This is the downgoing slab and this is the upthrown slab. This is the downthrown slab. This is the upthrown. Again I am repeating, this is the CS view, this is the cross section view, and here it is the map view. Okay, so this is the fault plane. This block moves down, this block, this side moves down. So what happened? Just like this is R, then Q, then P, and here you are getting like this P, Q, R. What happened? This block moved down and this block moved up. Okay, now what happening? I am passing a horizontal plane here. I am passing a horizontal plane here. This part will be eroded, right? This part will be the part above will be eroded. This is my surface, So now if I'll see the surface, it will become map. Now if I'll see from top, it will become map. So first you are getting P, then you are getting Q, then you are getting R, then you are getting P, then Q, then R. So PQR, then PQR. So here this is the fault plane. Here it is the fault plane, right? So this is repetition and this is repetition of strata, right? PQR and PQR. From here you can interpret like this. So the fourth one is the answer. So I hope all of you got it. Then moving to next question. So here the map question is associated with sedimentary structure, right? Here you can see this is cross bed. This is cross bed, right? Here it is asking that whether it is okay. So let me tell you one thing: antiform versus synform and anticline versus syncline. Okay, so antiform and synform, these are defined on the basis of shape. These are defined on the basis of shape. Antiform means closing up. This is antiform, closing up. Synform means closing down, right? This is closing up. Closing up means it is which view? Cross section view, right? So here closing down is your synform, What is the difference between anticline and syncline? So anticline means older at the core, syncline means younger at the core, right? When older is at the core, it is anticline. When younger is at the core, it is syncline, right? But regarding shape, it is antiform and synform. So thereby you can you can assemble like antiform anticline, antiform syncline. This is antiform. If I put it older and younger, so older is at the core, so antiformal anticline. If I'll do this is antiform and this is younger and older, so this is antiformal syncline. The shape is antiform. The shape is antiform in both the case. But here older core, so anticline. Here younger core, so syncline. Now this is synform. This is synform. If younger at the core, then it is synformal syncline. If older at the core, then synformal anticline. Both of them are synform, but here younger core, so syncline. Here older core, so anticline, right? So I hope all of you got this. Then moving to the question. So cross bed. So all of you know what is the cross bedding structure? Truncated top and tangential bottom, right? Truncated top and tangential bottom. You can see this is the top strata and this is the bottom strata, right? So the bedding is at high angle to the top strata. It is at high angle to the top strata and it is or top set. It is top set bed and it is bottom set bed, right? So it is at high angle to top set bed or top strata, then it is at low angle to bottom set bed, or it is at tangential, it is tangential to bottom set bed. Okay, so here the top bottom criteria is, this is the top and this is the bottom. Top means what? It is younger and it is older. It is older. So cross beds can show us what? Younging direction. So this is the younging direction. This is the younging direction. It can also show paleocurrent direction. In sedimentary structure, we are studying this. We can also get information of paleocurrent direction. This is the paleocurrent direction, right? And this is the top bottom criteria or younging criteria. So the direction at which you are getting high angle is your younger. Okay, so in the first diagram you can see this is the high angle side, this is the high angle side. So here you are getting younger. Here you can see this is the high angle side, so here you are getting younger. So inside older, here outside older. Okay, so from the shape you can know that it is antiform. This is antiform, but at the center you are getting younger, so this is syncline, antiformal syncline. Here this is synform, the form or the shape is what? Thin, or it is closing downward, so synform, and older at the core, so anticline, synformal anticline. So X is antiformal syncline and Y is synformal anticline. So the fourth one is the option. So this is from GATE 2020. This is asking about your culmination of antiform or culmination of synform, or depression of antiform and depression of synform, like that. So it is also a part of your this is a part of your GATE question, GATE paper, previous year GATE paper. So what happened? Okay, so this is a fold. Let me start with this. This is a fold. Okay, and it is the hinge line. It is the hinge line. Okay, now it is horizontal. Now it is horizontal. Now I'll make like this. So hinge line is plunging. Now this is horizontal. It is plunging in this direction. It is plunging in this direction. Okay. So here it is the hinge line which is horizontal, and here hinge line is plunging in this direction. So if you see, this is plunging in a single direction. This is plunging in a single, let's say it is north, so it is plunging south. It is plunging in a single direction. Okay, if it will plunge in both direction, then how can we draw the diagram? The same fold, just like this, right? If I'll do like this, okay, so this is the fold. So you can see the hinge line is plunging in both direction. It is plunging in both north and south. Okay, another way it can be like this. It can be like this, right? This is plunging north, this is plunging south. Okay, the same pole, it is an antiform. You can see the from the shape from previous slide I have told what is antiform. It is closing off, it is closing off, so it is antiform. So it is antiform. Okay, so antiform, if it is plunging in one side, this is the case. If it is plunging in two sides, these are two cases. In this case, you can see hinge line is plunging away. Hinge line is plunging away from each other, and here hinge line is plunging towards each other. Hinge line is plunging towards each other. Okay. Similarly, for synform also you can do. This is a synform. This is synform. Now the hinge is horizontal here. If I'll plunge it like in a single direction, now it is plunging in a single direction. If we'll plunge it in double direction, it will be like this. Like this, right? And if it will plunge, so here you can see it is a synform, and here it is plunging in this direction. Now it is plunging in both direction. Okay, now okay, now it is a synform and it is plunging towards each other. It is plunging away. Suppose it is north and south. It is north and south. So here hinge line is plunging towards, and here it is plunging away. Okay, so one thing you mark here, if arrows are away from each other, arrows are away from each other, you can see it is culminating. You can see it is culminating. If arrows are towards each other, it is depression, right? If they plunge away from each other, you are watching culmination. Okay, if towards each other, you are finding depression. Similar with synform, if they are plunging away from each other, you are finding culmination, right? If they are dipping or plunging towards each other, you are finding depression. If they are plunging towards each other, you are getting depression. If they are plunging away from each other, you are getting culmination. Okay, in case of antiform and synform, both, if they are plunging away, so culmination, plunging towards each other, so depression. So first thing you got it here, that they are, this is the plunge direction, this is the plunge direction of fold axis or hinge line. Okay, so there are difference between fold axis and hinge line. Okay, in previous video also I have told, but they are parallel. Hinge line and fold axis both are parallel in case of cylindrical fold. This is the hinge line, fold axis will be here. Okay, both are parallel. So you can see this is your plunging away from each other. This is plunging away. Plunging away. That means what? That means what? It is culmination. This is culmination. First thing is clear. It is culmination. Okay. Now you can see this. This is a map view, right? This one is your map view. This is map view, right? So you can see this thing. Now let's focus on this. First we have focused on the arrows, so they are plunging away from each other, so it is culmination. So we have three options now, A, B and C. Depression is caught. Okay, then we'll move to this one. We'll move to this part. What is this? This is closing of outcrop. This is closing of outcrop, right? The outcrop is closes here. Okay. So now this is the antiform. This is the antiform, right? This is the antiform. Let me plot it here again. This is the antiform and it is plunging. If I'll pass a horizontal here, horizontal plane here, if I'll pass a horizontal here, I have told you map means you have to see in horizontal. So if I'll pass a horizontal plane here, so it will cut the fold here. You can see this is the closing end. This is the closing end. It will be like this. This part is the, this part I have plotted here, right? This is the horizontal plane. This is an antiform which is plunging in this direction. Let's say this is south and this is north. So it is plunging towards south. So it is closing towards south. This closing is also towards south. You can see if I'll pass a horizontal plane here, this side is open. This side is open and it will cut it like this. It will cut it like this. So it is closed. So it is closing towards south. For an antiform, the plunge direction and closing direction is same. Okay. For an antiform, plunge direction is equal to closing direction. From here you can see, right? Plunge direction is towards south and close direction is towards south. For an synform, let me erase something or I'll plot it. Okay. So for a synform, okay, so let me erase this one. So this is a synform. This is a synform, right? Now I will pass a horizontal here. I will pass a horizontal here. I will pass a horizontal here. This is a synform. As you can see, and it will close like this. Okay, this is the horizontal. This is the horizontal I have passed. You can see this part will be closing and this part will be open. This is the open part. So this side it will be open and it will close this side, right? This is the horizontal surface. Here I am, here it is the horizontal surface, right? Now you can see this is the hinge line. This is the hinge line, right? This is the hinge line or fold axis. Fold axis is somewhat here. I have told you that it is the hinge line. So it is plunging towards, if it is south and it is north, so it is plunging towards south. It is plunging towards south, but it is closing towards north. It is closing towards north. This is a synform. This is a synform which is plunging towards south but closing towards north. Okay, it is plunging towards south and closing towards north. So that means for synform, plunge is opposite to, plunging direction of axis is opposite to closing direction of outcrop, right? Here plunging and closing are opposite. Here plunging, for antiform, plunging and closing are same, right? I hope all of you got it, that plunging and closing are opposite here for synform and plunging and closing are same for antiform. So you can see here it is the plunging direction and it is the closing direction. Here it is the plunging direction and it is the closing direction. These are opposite to each other. Plunging and closing are opposite to each other. So it is a synform. It is a synform, right? So it is a synform. From first thing they are plunging away from each other, so it is culmination. Then plunging is opposite to closing, plunging is opposite to closing, so there is synform. Okay, so culmination of synform. Again there is another term, whether syncline or anticline. Now I am erasing everything. So we have known now, it is clear that it is culmination and it is synform. Okay, culmination, why? Because they are plunging away from each other. Why synform? Because this is the closing direction, which is opposite to plunging direction. Closing direction is opposite to plunging direction, so it is culmination of synformal. Then the next term is whether it is anticline or syncline, whether it is anticline or syncline. So for anticline, we should have older core. We should have older core. For syncline, we should have younger core. Right? We should have older core for anticline, or we should have younger core for syncline. So the direction is given here. It is the older and it is the younger. Okay, so this one is younger, this one is older, older and younger. So there is younger core. So we are having younger core. So it is synformal syncline, synformal syncline. So it is culmination of synformal syncline. Okay. So I hope all of you got this, and you can do it in exam also. You need not memorize this, you can solve that. Okay. Okay, so there is one mistake I hope in this question, which is this one. This one along with because it is synform, it should, the limbs should, it should be like this. It should be like this, right? Because it is synform. Synform means what? It is, it should, the limbs should plunge towards the core. The limbs should plunge towards the core, right? The limbs should plunge towards the core. So I hope it will be towards the center. This thing may be wrong in the question paper. Okay, so it is culmination of synformal syncline. So the option is D. Then moving to this question again. So you can see this is the folded and faulted sequence of beds given in the map below. The fault FF. Okay, so this is the fault plane. This is the fault plane here, and which is dipping in this direction, which is dipping in this direction. So this block will be the what? This block will be the hanging wall. This block will be hanging wall. This is the hanging wall and this is the foot wall. Why? The block which rests over the fault plane. The fault plane is dipping northward, northeastward, right? Northeast. If this is north, this is north, means this side is northeast. So the fault plane is dipping northeast. So this block is your hanging wall which rests over the fault plane. Now it is the foot wall, okay, which is below the fault plane. It is the foot wall. Okay, it is a question of gate 15, right? So now you can see from the, okay, let me clear this. Then you can see this one. Then moving to this part. What is this? It is dipping away from each other. The limbs are dipping away from each other. That means if this block is not faulted, it can be like this. It is like this. Okay, it is like this, and it is dipping away from each other. Okay, if the block, when the block is not faulted, it might be like this. Okay, this is dipping away from each other. So let me draw a diagram like this. Let me draw this block diagram, right? So this is like, see, this is like this, right? And these are dipping away from each other. Here it is the surface, so you are watching the map. Let's go to the cross section. Okay, so these are dipping away, so it can be like this. This is like this. That means what? As you move down, the width will increase. The width will increase as you move down. The width here is wider than this. Now this part is wider than the above, because they are dipping away from each other. The width is increasing. Okay, so if you see the original, if it is not faulted, if the block was not faulted at the beginning, the width is like this. Okay, this is width. So then the width is increasing. You can see the width has increased to this much. Now the width has increased to this much. That means what? We are going to deeper side. But this is a map. That means what? This deeper part is exposed. Suppose it is the total block. Here, which is the total block, right? And here the fault takes place. Here it is the fault. Then what happened? This block moved off and this block moved down. Okay, so this is the foot wall side and this is the hanging wall side, right? From diagram you can correlate. This is the foot wall and this is the hanging wall. The fault plane is dipping in this direction. Right? Then this part moved off. So the hanging wall moved off. Why it is moving off? Why I am so sure that it is moving off? Because the width is increasing. You can see this part. If you go deep inside, then only the width will increase, because they are dipping away from each other, because the limbs are dipping away from each other. If you go downside only, the dip will increase. If you will move offside, the width will decrease. Okay, in the offside you can see from here, this is W2, this is W1. From W1 to W2, width is increasing. Okay, from W2 to W1, width is decreasing. So we cannot move up, we have to move down. Okay, so we cannot move down, either we have to move down or the block can move off. Either foot wall will move down or hanging wall will move up, right? We have to expose this part, right? We have to come to this part, so either foot wall will go down or hanging wall will move off. But here you can see the fault plane is dipping towards northeast, this side. This part has moved off. That means the hanging wall moved off over the fault plane, right? The hanging wall moved off over the fault plane, because of which the deeper part exposed. Deeper parts are exposed. How do you know the deeper parts are exposed? Because we are getting wider. but more separation between the limbs. We are getting wider separation between the limbs. This can only happen when this block moved up. So when the hanging wall is up thrown side, so it is a reverse fault. It is a reverse fault. Okay, I hope all of you got it. Then JAM 2020, it will be the last question. So yes, so from this diagram, okay, so it is asking, this is asked in MSQ, this is asked in multi-selection question. So there may be 1 or 2 or 3 or 4, whatever, right? There can be either one answer or can be many options. So for the first time when you look at this diagram, then there is, it is I need not explain this. I need not explain this because it is very clear from the picture itself. From the picture itself, you can see if it is, this is the map view. I am also plotting the map view right now. So these are the lines. Now they are not faulted. After faulting, what happens? They move aside like this. So this part moved this direction, this part is moving in this direction. Okay, so from this you know that it is moving along the strike of the fault plane. So it is strike slip. It is strike slip fault. It is a strike slip fault. From the diagram, from the first look, you can say that it is a strike slip fault. Okay, so how do you know? Then the next challenge is whether it is dextral or sinistral. Dextral or sinistral. So most of the time people get confused with this. So I will give a clear picture of that. Okay, so this is the block, right? This is the block like this. Okay. Initially this is like this, then it is faulted and then moved like this. Okay. So what you have to do, you have to stand on any of the block. Either you will stand here or you will stand here. Suppose X and Y. Suppose I will stand at Y. Okay, if I am standing at Y, the X block is moving and I will see at X. Okay, I will stand on a block, I will stand on a block and I will see the opposite block. I will see that the block is moving towards left of me. Okay, similarly if I will stand at X, similarly if I will stand at X, I will stand at X and I will look at Y. I will stand at X, I will look at Y. Okay, I am standing here and I am looking at Y. This block is moving towards left. This block is moving towards left. I am looking at Y. Okay, stand on a block and look at the opposite block. Here I have here I am here at Y and looking at X. Block is moving left. Here also I have stood at X and looked at Y. Y is moving towards left. Same diagram, right? So it is left lateral. This left lateral fault. Okay, or sinistral, or sinistral. Okay, if the block is like this, so it is moving like this. So what I will do, this is X and this is Y. So I will stand here on Y, I will look at X and I will see that X is moving towards right of me. Or what I will do, I will stand at X, I will stand here, okay, I will look at Y and I will see that Y is moving right of me, right? If I will stand at X, I will look at Y, Y is moving towards right of me. If I will stand at Y, look at X, X is moving right of me. So it is right lateral, is right lateral, or else it is dextral, or else it is dextral. Okay, so from this diagram you can see, if I'll stand here, I will stand here, I'll look at the opposite block, it is moving left of me. I am standing here means I am not going to see this south block, I am not going to see this south block, I'll look at north block. I am standing at south block, so I'll look at north block and I'll see that it is moving left of me, so it is left lateral or sinistral. So it is sinistral. Okay, so let me erase everything. So first thing is it is sinistral. Okay, then there will be another option. So let's start that. Suppose this is the block, this is the block, and these are the beds are dipping towards, so this is north, so beds are dipping towards northwest. Okay, so let's say this is your north side, this is your north side. Okay, so what happens, the beds are like this, beds are like this. Okay, and they are dipping towards west, they are dipping towards west, so beds are dipping like this. Okay, the fault is dipping towards north, so it is the fault plane, it is the fault plane which is dipping towards north. This is the fault plane, it is dipping towards north, fault plane is dipping towards north, and the beds are dipping towards west, beds are dipping towards west. Okay, so as you see this one, as you see this north block, this is the north block, this part is the north block, and this part is the south block, this part is the north block. Again I am plotting same diagram here. So this is like this. Okay, this is the fault plane. Okay, now displacement is not there, if displacement will be there. Okay, so if I'll move this, you can see the blocks are, you can see the blocks are moving, or the contacts are displaced towards the deep direction. The contacts, these are the contacts, right? You can see they are in a line. Before displacement they are in a single line, before displacement they are in a single line. After faulting, what happens, they are displaced in, this is the dipping direction, this is the dipping direction, so they are migrated to here, they are migrated here, they are migrated here. So you are getting it right here. Okay, as you move down, you can see this is the surface, this is the surface. As you move down, you can see the beds are moving, or the beds are, in the first case the bed is here. Okay, in the first case bed is here, this is the contact, right, and it will move to here, this is the displacement. As you move down, the bed will displace, as you move down, the bed will displace. In which direction? In the direction of dip of bed, right? As you move down, this is the north block and this is the south block, this is the north block and this is the south block. As we move down in north block, you can see the displacement, or you can see the separation of the contact. Okay, these are moving towards the deep direction. You can see the contacts are displaced towards the deep direction. Okay, from the diagram also you are seeing that the contacts are moved in a, or displaced in a direction which is same as deep direction. Okay, the contacts earlier they are here, earlier they are here, but now it is moved to this direction, and this direction is same as the deep direction. Okay, so you can see as you move down also, this part is cross section view. Okay, this is your map view. In cross section, if you see, as you move down, the beds or the contacts, they are moving towards what? This is west. They are moving towards west. The contacts are moving towards west or in the deep direction. That means what? This block moved off, this block moved off, and this part got eroded, and this part got eroded, right? Like this. I am telling it again here, right? So this is the fault plane, this is the fault plane, and it is the contact like this. So this part moved off and this part got eroded. This part got eroded. So instead of getting contact right here, you are getting contact right here. This is the contact, right? Instead of getting contact here, the contact is moved in the deep direction. It is moved in the deep direction to here. You are getting the contact right here. This part is moved off, right? So the diagram becomes like this. This is the fault plane, and now they are shifted. Now they are shifted. Why they are shifted? Because this part is moved off. This part is moved off, then this part got eroded. This part got eroded. Now you are seeing this one. Now you are seeing these contacts. So the fault plane is dipping towards north. The fault plane is dipping towards north, and the north block is moving off, and it is moving off. So north block is the hanging wall because it is resting over the fault plane. North block is resting over the fault plane, so it is hanging wall, and south block is foot wall. So hanging wall moved off. Hanging wall is moving off. So it is a reverse fault. So it is a reverse fault. Okay. I am doing it again if someone has not yet understood. So I am trying to do it again. This is the fault plane. This is the fault plane, right? This is the fault plane. This is the north block. This is the south block. Fault plane is dipping towards north. These are the contact earlier, and the beds are dipping towards west. Beds are dipping towards, this is west, this is east, right? So they are dipping towards west. What happened? They moved off. They moved off like this. They moved off like this, right? I hope all of you getting. This block moved off. Okay, let me erase something so that you will. Okay, now you can see. Now you can see this part moved off. This is the north block. This is the south block. In south block you are getting contacts here. Here also you are getting contacts at the same location. Okay. Let me erase one more line. This one. Okay. Now it is clear. And it is moving like this. Okay. Now what happened? This is the off thrown side. Okay, north block is the upthrown side, so hanging wall moves up. Then what happened? This part got eroded, this part got eroded, this part got eroded. So instead of getting contact here, now the contact is you are getting the contact at right here. Instead of getting it here, you are getting it here. So the final diagram becomes like this. This is the fault plane, and you can see like this. Okay, so here it is the contact, but the upper part is eroded, so you are getting it like this. So you are getting this displacement, you are getting this displacement, and the displacement is in a direction of west, which is the deep direction of bed, The fault is dipping north, the bed is dipping west. Okay, so it is reverse and sinistral. So I hope I have tried my best to make you understand all the questions. That is because this 6 question, I have put 6 question, but it took so long to explain this. So I hope all of you got this. Thank you, and stay tuned for further videos.